Next chapter, product of vectors. In this, the important points are scalar product. Definition or the condition of the scalar product is the two vectors, A vector and B vector are the two vectors. Then dot product in between of the two vectors is equal to modulus of A vector into modulus of B vector, and the angle in between of the two vectors cos of A comma B. Then it is known as the scalar product or dot product of the vectors. Okay. The second one in this, that is the first point. The second point is the, for the scalar vector, the cos of A vector comma B vector means the angle between of the two vectors. It is denoted by the theta angle. Then cos theta equal to A vector dot B vector by modulus of A vector into modulus of B vector. It is the angle. From this only we are getting. Why? Because it is the, suppose B angle, B vector, it is the A vector. The angle in between of the two vectors, if it is theta, then we can taking it as cos theta is equal to the angle in between of the two vectors A and B. This is the scalar product. Next we can take the vector product. The dot product is called as the scalar product. The cross product is called as the vector product. The definition of the vector product or condition of the vector product is, in this, A and B are two non-zero, non-collinear vectors and theta is the angle between of A vector and B vector. Then A vector cross B vector is equal to modulus of A vector into modulus of B vector into sine theta. Here, n vector is known as vector product or cross product of A vector and B vector. So, n vector is the unit vector that is perpendicular to both A vector and B vector. Here we are taking, this is the A vector. Here we are drawing, it is the n vector, means it is perpendicular to B vector and this is same as perpendicular to A vector. That is nothing but it's upwards. Upwards means the direction, how the x-axis and y-axis, z-axis are there, the same thing. Here also the normal vector n vector is perpendicular to A vector and B vector. When it is perpendicular, then cos 90 degrees, it will be 0. Then A vector cross B vector is equal to modulus of A vector and B vector. In this, the dot product, in the dot product, the directions are same. That is A vector dot B vector is equal to B vector dot A vector. But in the cross product, A vector cross B vector is equal to minus of B vector cross A vector. Here the dot product means we can take A vector cross B vector can be calculated in the determinant, that is equal to modulus of I, J, K, A1, A2, A3, B1, B2, B3, where A vector is equal to A1I plus A2J plus A3K. Here I, J, K are the unit vectors along x-axis, y-axis, z-axis. B1I plus B2J plus B3K. From this, the cross product in between of two vectors means we take the determinant of the vector, unit vectors and components of I, J, K for A vector and B vector. In this is the vector product of two vectors. Okay, this is nothing but scalar. Next, we can take the another definition, scalar triple product. Scalar triple product means we can take the three vectors. Those are A vector, comma B vector, comma C vector, or the three vectors. And the scalar triple product can be defined as, we can take the cross product in between of the first two vectors, and again we are getting the vector and dot product with the third vector. This is known as the scalar triple product. In the scalar triple product means the vectors are three vectors, in between the dot and cross is there. And it is also denoted by the volume of A vector, B vector, C vector. And simply we can take it as modulus of A1, A2, A3, B1, B2, B3, C1, C2, C3 determinant. Why? Because after the cross product, we are getting the vector dot vector, we get the scalar. See, we know that I dot I equal to J dot J equal to K dot K equal to 1. So the dot product in between of the two vectors, we get the product is 1 for the other opposite. I dot J is equal to J dot K equal to K dot I is equal to 0. From that, we are getting the scalar value. It's not a vector. So then it is said to be the scalar triple product. That is nothing but we can take the cross product in between of the first two vectors, and that vector is as, taking the dot product in between of the third vector, and that is equal to the determinant of the three vectors, where A vector is equal to A1i plus A2j plus A3k. B vector is B1i plus B2j plus B3k. C vector is equal to C1i plus C2j plus C3k. This is the scalar triple product. It's over. Next definition is the vector triple product. Vector triple product means we can take the three vectors, A vector, B vector, C vector. The vector means after taking the product in between of the three vectors, again we are getting the vector. How we are getting the vector? If the cross product between the two vectors, we get the vector. Again cross product between the third vector is also get the vector triple product. That is nothing but in the three vectors we can take in as a cross product, then we get the vector only. So it is called as a vector triple product. In the previous, we can take the cross product. After that, taking the dot product, get the scalar. So the definition is called as a scalar triple product. In this, if the node points are, if L, M, N are direction ratios or direction quotients. The difference of the direction ratios means those are DRs, ratios. In the ratios case, L square plus M square plus N square by under root of L square plus M square plus N square is equal to 1. If L, M, N are DCs, then DCs means if and only if, or it satisfies the relation L square plus M square plus N square is equal to 1. If L, M, N are DRs means then L square plus M square plus N square by under root of L square plus M square plus N square is equal to 1. Next, note, if three are the points, three vectors or three are points, vector points on the lines, A is A, X1, Y1, Z1, B is X2, Y2, Z2, C is the X3, Y3, Z3 or the three vectors are on the same line means then it satisfies the relation the determinant of the three vectors should be 0. If the determinant of x1, y1, z1, x2, y2, z2, x3, y3, z3 equal to 0, then A, B, C are collinear. If the 3 points are on the same line, we can say that it is the collinear. When we can say that these are collinear means if its determinant should be 0, then 3 points are collinear or three vectors are collinear. Next point is if we can take the P is a point dividing the line AB. If the P vector is the position vector, if the vector is divides the AB line in the ratio of M and N, then the dividing point is if it is internally, then the point becomes is or the vector is MB vector plus NA vector by M plus N. If the point is divides externally, if it is externally, then R vector is equal to MB vector minus NA vector by M minus N. Here OA vector is equal to A vector, OB is equal to B vector. These are important. How to find out internal point and external point when the P point is the position point dividing the line AB. Okay, next point, if capital R is a midpoint of line segment AB, then the position vector of capital R is equal to A vector plus B vector by 2. Midpoint means we can take the average. Next point, it is very important. R vector is equal to A vector plus TB vector it represents the vector equation of the straight line passing through the point A and parallel to the vector B, and T is a real number. It is the same as addition of the vectors. R vector equal to A vector plus TB vector means the vector is passing through the point A and parallel to the vector B. Then the vector equation of the straight line is A vector plus TB vector. Next, it is also same as the addition of the vectors. That is R vector is equal to 1 minus T into A vector plus TB vector, where T belongs to capital R. It represents the vector equation of the plane passing through the 2 points. If it represents the vector equation of the line vector equation of the line passing through two points AA and BB points. Next, third one, R vector, or this is a vector equation, 1 minus T minus S into A vector plus TB vector plus SC vector. It represents the vector equation of the plane passing through the 2 points and parallel to the another point or another vector. 1 minus T minus S into A vector plus TB vector plus SC vector. It represents vector equation of the plane passing through two points AA and BB and parallel to C vector. These three are same as the addition of the vectors only. First, A vector plus TB vector represents the vector equation of the straight line passing through the one point and parallel to the another vector. 1 minus T into A vector plus TB vector represents the vector equation of the line passing through 2 points. Third one is R vector equal to 1 minus T minus S into A vector plus TB vector plus SC vector. It represents the vector equation of the plane passing through the 2 points and parallel to the another vector. Next definition, it is very, very important. The projection vector of B on A vector is B vector on A vector is A vector dot B vector by modulus of A vector square into A vector and its magnitude
Hello.
the projection vector of B vector on A vector is A vector dot B vector by modulus of A vector. On which vector is that will comes in the denominator modulus square into A vector and its magnitude is modulus of A vector dot B vector by modulus of A. Okay. When they are asking about the projection vector of B on A means this is the formula. And if A vector is equal to A1I plus A2J plus A3K and B vector equal to B1I plus B2J plus B3K, then the dot product in between of the two vectors A vector dot B vector equal to A1 B1 plus A2 B2 plus A3 B3. Why? Because we know that I dot I equal to J dot J equal to K dot K equal to 1. The I dot J equal to J dot K equal to K dot I is equal to 0. The angle in between of the two vectors is theta, then cos theta equal to A1 B1 plus A2 B2 plus A3 B3 by under root of a1 square plus a2 square plus a3 square under root of b1 square plus b2 square plus b3 square. Here, where theta is the angle in between of the a vector and b vector, modulus of a vector is equal to under root of a1 square plus a2 square plus a3 square. Similar to modulus of b vector is also b1 square plus b2 square plus b3 square under root. Next definition or condition of the vector equation of the plane passing through the point and perpendicular to the vector n is r vector minus a vector into n vector is equal to 0. This is the vector equation of the plane passing through the point AA and perpendicular to vector n is r vector minus a vector into n vector is equal to 0. Next point, if theta is the angle between two planes, theta is the angle between two planes, then cos theta is equal to modulus of n1 dot n2 vectors, where n1 and n2 vectors are unit vectors, unit normal vectors of the plane. Of the planes. That is nothing but this is the one plane and it is the another plane. The angle between this is theta. And we are taking n1 vector and n2 vector for two planes. Next, how to find out the cross product in between of the two vectors. We know that a vector and b vector is a1i plus a2j plus a3k cross b1i plus b2j plus b3k. That is nothing but determinant of I, j, k, a1, a2, a3, b1, b2, b3. So here the cross product in between of the two vectors means I vector into a2, b3 minus a3, b2 minus j into a1, b3 minus b1, a3 plus k into a1, b2 minus a2, b1. If we can take I means we can elimination of corresponding row and column and find the minor matrix determinant a2, b3 minus a3, b2. Next, it is in the first row minus 1 whole power first row and first column, that is the positive. It is minus 1 whole power. Determinant means the first row, second column means it will be negative. So minus j into elimination of the corresponding row and column. Again the determinant a1, b3 minus a3, b1. So plus k means again we can eliminating the or corresponding row and column and take the minor matrix determinant. So this is the cross product in between of the two vectors. Next, it is also very, very important. Unit vectors perpendicular to non-collinear vectors. Perpendicular to non-collinear vectors A vector and B vector, or plus or minus A vector cross B vector by modulus of A vector cross B vector. This is the condition of the unit vectors perpendicular to the non-collinear vectors. That is A cross B by modulus of A cross B. Next, vector area of triangle ABC is half of AB vector cross AC vector. It is equal to half of BC vector cross BA vector. It is equal to half of CA vector cross CB vector. It is a triangle ABC, means we can take it is A, B, C. Here AB vector cross AC vector, in that half is there. In the same way, BC vector into BA vector, in the same way CA vector into CB vector. That is the vector area of the triangle ABC. Here one more condition, A vector cross B vector dot C vector is equal to volume of ABC vectors, and it is equal to B vector, C vector, A vector, it is equal to C vector, A vector, B vector. These all are same. And here A, B, C is nothing but determinant of A1, A2, A3, B1, B2, B3, C1, C2, C3. Already I explained there only. This is. Next condition of volume of parallelepiped. Volume of parallelepiped with edges. A vector, B vector, C vector is V is equal to volume of A vector, B vector, C vector, that is determinant if A vector, comma B vector, comma C vector is right-handed system. The second point is if V is equal to minus of A vector, B vector, C vector, if A vector, comma B vector, comma C vector is a left-handed system. Left means we get the negative, right means we get the positive. Next, what is the coplanar condition? Coplanar means three planes are on the same, three vectors are on the same plane, then that is called as the coplanar. If we are taking three planes, means that is A vector, B vector, C vector and D vector. Here these are points, these points are coplanar. If these points are coplanar, means then the volume of AB, AC, AD is equal to 0. It should be 0 if and only if. If the three vectors are coplanar means directly we can take A vector, B vector, C vector is equal to 0, then three vectors are in coplanar. If A vector, B vector, C vector are coplanar, then if and only if volume of ABC is equal to 0. Next, volume of tetrahedron. The formula of the volume of tetrahedron with A, B, C vectors, then those are edges, then we can take the volume of tetrahedron is 1 by 6 into determinant of A vector, B vector, C vector. Its magnitude, that is nothing but a volume is always in positive only. So volume of the tetrahedron. And if P, Q, R, S are the vertices, these are the vertices, then the volume of the tetrahedron V is equal to 1 by 6 into modulus of SP, SQ, SR. This determinant.